spermatogenesis was seen. Testicular tissue fragment was cultured. It was maintaining to some extent, but the differentiation did not happen because inducing meiosis in vitro is a highly complex process. We have not understood the mechanism, the physiology, the mechanism behind meiosis. And 3D culture was done, but again didn't maintain normal structure. Differentiation was seen post-meiosis. There are few post-meiotic cells spermatids, but it didn't progress before. 3D culture system was done where testicular tissue was cultured in a soft agar and cultured for about 72 days, and they could see sperm here after 72 days. But again, as you see here, this was done in mouse model. These are the packaging spermatocytes. When they cultured, they could see sperm inside the agar. But unfortunately, the viability was not maintained. It was not possible to use these sperm cells for fertilization, so the technique failed. But there's a group, there's several studies, the Japanese group, the Saga group, they have published several papers in Nature, have been publishing since last 3-4 years. They are successful. They could derive sperm in vitro, they fertilize the sperm by ICSI, and they could see the progeny, offspring in mouse. So that means the technique works in mouse. To mimic it clinical situation, because usually in the clinical situation we don't use fresh tissue. We have to freeze and later we need to use it for producing sperm. The frozen testicular tissue was used here, and again the same group could produce sperm when the frozen testicular tissue was used to derive mature spermatozoa. And you see here, these are the agar culture was used. Agar culture was, soft agar culture was used. It was in case of organ culture. And there are some other papers which they use the induced pluripotent cells for culture, and they could produce spermatozoa. And interestingly, in 2015, with the French group, which said that they are successful even in human, they could produce sperm, but the technology, they used the bioreactor to derive spermatozoa, but they did not reveal the technology, how it is done. And by culturing the testicular tissue for about 61 days, they could derive sperm or sperm-like structure. In fact, people are not agreeing to that because we really don't know whether it is really spermatozoa or something else. And recently, the Spanish scientists, they grow human sperm in a lab. The cocktail of genes were turned skin. They use the somatic cells, they use skin cells by the IPS technology, induced pluripotency, and they would derive sperm. But again, the lacuna here is that the efficiency of spermatogenesis. It is not possible to get millions of sperm like how test is produced here, and efficiency is not shown. And secondly, the offspring production reported only in mouse. So far, we are not successful in human. There are no reports on autografting of human testes. And more importantly, safety. How safe these cells are, because we are not sure about the genetic and epigenetic components of these cells. In fact, we are working in Manipal in collaboration with the various labs in Europe, and in fact very recently we are successful in mouse because we are first step. We could derive sperm in vitro, but you use a 3D agar. After about 61 days we could derive mature elongated spermatozoa, trying to see the functional competence of this sperm, whether it can fertilize the oocyte. And importantly, we are also parallelly we are trying to use human tissue to see whether we can. At present, I cannot reveal this data because we have a disclosure. To conclude my presentation, live births have already been achieved using in vitro derived gametes of varying source in animal model. But again, the data on the safety of these cells are not very clear. The clinical use of in vitro derived gametes would expand the treatment possibility, especially in case of, and there are a lot of benefits. And there's the potential, before potential clinical use, and then we should look into the social as well as ethical implications of these so-called artificial gametes. So the future direction is to generate viable, motile, morphologically normal sperm to make sure that it completes in vitro meiosis in human and produce live birth. Establishment of stable culture system and optimize of culture medium, and genetic stability is important, and genetic as well as epigenetic stability of these cells. In fact, we are working in, we have Center for Fertility Preservation, which is a dedicated center as a part of Manipal University, which is In collaboration with various European centers, we are providing clinical service, and we are also involved in training, and several collaborative projects have been undertaken with the generous funding from the Alexander Van Humboldt Foundation, Germany. Thank you very much for your patience.
Thank you very much, Dr. Satish, for that talk, which holds a lot of promise to a lot of people. To give the next lecture on testicular vein ligation, modern perspectives, I call upon Dr. Vineet Malhotra for the next 15 minutes.